Hello, statisticians. Mr. Youngsaver here from Skew the Script. Today we're talking about describing and exploring quantitative data. This is a technique lesson that will help us analyze data sets later on in the course. Let's skew it. Today's lesson is on describing quantitative data. This is Unit 1, Lesson 3 in our sequence. If you want to follow along using notes, please go to our website at this URL. There are no hot topics we're exploring today. This is more of a technique lesson to let us analyze later issues in the course. So we're going to start with talking about frequency and relative frequency for quantitative data. Imagine we have a data set of 12 salaries at a company of 12 employees. In this data set, the numbers represent thousands of dollars. So for example, the first person in this data set makes $39,000, second person makes $34,000, etc. We can take these salary data points and show their frequencies. One person made $29,000, the lowest salary value in this data set. One person made $32,000, four people made $34,000, etc. So this is a nice little summary of the data set that we have for a total of 12 salary data points. Now, we can take the frequencies and convert them into relative frequencies as well if we want to get percentages. So in this case, we have 12 total salaries, 12 total data points, and we can divide the frequencies by that total to get the relative frequency, the percent. One person made $29,000 and 1 out of 12 is 8.3%. So 8.3% of people in this company made $29,000. And for example, for $34,000 salaries, there were 4 of them, which is a third of 12 or 33%. Now let's talk about different ways to visualize these frequency tables. First, let's start with Dotplots, probably the simplest visualization in this course. For a dot plot, you take the salaries and their frequencies, and you put them on a number line, and use the y-axis to demonstrate the frequencies. This gives a little bit of shape to the distribution, lets you see what the distribution of data looks like. Now, always, always, always when you're graphing in this course, remember title, tick, tick, label, label, label. The amount of ticks, the amount of labels in your saying here doesn't matter. Just know I need to put titles, I need to label things, and I need to put tick marks to show scale. If you do those things, you avoid making misleading graphics a lot of times, and you get extra points on FRQs in which you have to draw graphics. Now, for this case, I have a title, salaries of a company. I've included tick marks in the scale on my y-axis and a scale on my x-axis. I've also labeled both axes, frequency on my y-axis and the actual value of salaries on my x-axis. And you can see here, I visualize the frequencies with the heights. We have 4 data points at 34,000, we had 2 at 35, etc. We also get to see with this visualization how much of an outlier, how much of an unusually high value this person made $185,000 is. Maybe this is the boss of the company. Stemplots are a more detailed visualization than Dotplots, and we're going to go into how to do them now. So for Stemplots are divided into 2 categories. Here's what a stem plot for this data set looks like. This is divided into stems and leaves. Stems are the higher place value of your data points, and leaves are the lower place value of data points. In this case, I'm going to include a key. This key, 3 dash, well not dash, but vertical line 2, represents a worker with a salary of $32,000. That's this worker right here. So the stems represents the 10,000ths place and above, and the leaves represents the thousands place. So we can see, as with our frequencies, there was one person made $29,000, and then we've kind of grouped them together. All the $30,000 people are going to be in the same stem, but we're seeing how many there were, as well as their actual values, 32,000, 34, 34, 34, for the 4 people made $34,000, etc. And again, we get to see how much of an outlier this person who made $185,000 was. Now, you might be tempted with a stem plot to not do any labeling. Basically, the main label you need to do for a stem plot is to include a key so they know what kind of units you're talking about. In addition, you might also be tempted to exclude a lot of the empty space here. There are a lot of empty stems between the person who made $67,000 and this outlier high amount, $185,000. You might be tempted to do this, make your life a little bit easier. Don't do that. When you do that, you are not giving an accurate sense of how unusual that one person's data point was, and so you're creating a potentially misleading graphic. Now let's talk about probably the most common way to visualize quantitative data, the histogram. In histograms, you're going to take our frequency tables and convert them from individual data values into group data values. So for example, one natural way to group this data set is to look at all the salaries that are between $20,000 and $29,000, $30,000 and $39,000, $40,000 and $49,000, etc. Count up the number of people who have salaries in those categories, and then find the relative frequencies if we want a relative frequency histogram. That's how this works here. So we can take those categories and visualize them in a histogram like this. Note, I'm still title, tick, tick, label, label, labeling. I got a title here for my graph. I've labeled the axes. I have tick mark string scale for both axes. And what you can notice here is this is not a bar plot. This is not a bar plot. Bar plots are for categorical data, and they have space between each bar to show the different categories. This is a continuous data set, meaning that we have not just 20,000 and then 21,000, we have 20,000, $20,001, $20,002, all the way to $29,990, and then $30,000. So very small gradations there. So our bars kind of hit up against each other as we plot this data. This histogram gives us a sense of the data shape, and also, again, we get to see how much of an outlier that last data point was. There's another version of histogram called a relative frequency histogram, in which we, instead of graphing the frequency on the y-axis, the number of data points, we graph the relative frequency, the percent of the data in that category. The way we describe quantitative data sets and graphs is with a technique I call CSOCS. When you're asked to, quote unquote, describe a distribution, if you have an FRQ asking you to describe a quantitative graphic, you need to do the following things. You need to touch on its context, talk about what variables are being measured. You need to talk about the shape of the distribution, any outliers or unusual points that you see, the center of this distribution, and the spread. Today, we're going to talk about specifically skew and symmetry. Outliers, we're going to talk about the general center. We'll talk about means and medians later. And we'll talk about the range, and we'll talk about other measures of spread later on. So when we talk about shape, there's multiple ways to describe a shape. Oftentimes, data takes on a unimodal shape, meaning that we have one mode, one most frequent value, that is this large hump here, with lower values and higher values being less frequent. So there's generally a lot of data points around a certain value with some drop-off. In bimodal distributions, there might be two humps. And polymodal, you'll see many humps, but those are pretty rare, as well as bimodal are pretty rare as well. Most data is going to be unimodal. Another way to describe shape is in terms of skew and symmetry. We can see here that the way we describe skew and symmetry is if you see a hump on the left with a tail on the right, if the data tails off on the right, that's a right skew. Think about the skew follows the tail. On the left here, well, the right side of the screen, we have left skew, where we see the humps on the right side, and then the modes on the right side, there's a left side tail. So the data tails off on the left. So most of the data has higher values, very few of the data has lower values. That means it's a left skew. Right skew means most of our data has lower values, very few data points have higher value. And of course, symmetric means that most of the data is closer to the center with some even drop off on both sides. So remember, skew follows the tail. Tail on the right, right skew, tail on the left, left skew. And for our organization, Skew the Script, we play off this concept. We have a logo, and there's obvious skew here. The type of skew is left skew. The tail is on the left. Most of the data appears to be on the right. So the reason that we made this our logo is that when you learn statistics in a bad way without focusing on really understanding critical thinking, without really understanding statistical reasoning, without having orientation towards real world data, you might see in your class many low scores and few high scores. We see a right skew with the scores. If you really focus on critical thinking, statistical reasoning, and making sense of real world data, you will see many high scores on exams like the AP exam and very few low scores. We see a left skew, the tail's on the left side. So that's where the idea behind the logo comes from. We're gonna go through an example of describing a full distribution now. So when you get a question that asks you to describe a quantitative distribution, you want to think, again, CSOCS, context, shape, outlier, center, and spread. In this case, this data is of ACT scores from a stats class. So we're going to include that context saying these are ACT scores from a stats class. The data takes a shape of roughly a left skew, and one way we can determine the shape is just by drawing the outline. So we can look here and we see that it starts with a hump and then it has that tail. It's a slight tail, so it's a slight left skew, not an extreme one, but it definitely is there. This data is also unimodal. We don't see multiple humps. There are no apparent outliers. There are no gaps between these bars. There's no very unusually high or unusually low values. When describing the center, that can be a little bit tricky. In this case, the center is probably a score between, an ACT score between 24 and 27. The reason I say that is because that's actually the median for this data set. If you look at the values in those different bars and you kind of cross them out, getting to the central value, you would get a score somewhere between 24 and 27 for this data set. There is a rough estimate for a center that we do where we kind of just visually look at it and see where is roughly that median, that middle value here. We're going to describe a more precise way for getting centers in our next lesson. So stay tuned for that. In the meantime, just think about where is that central value roughly. The spread also has a rough value in this case. We're going to look at the minimum value and the maximum value and look at how much the data varies between that minimum and maximum. For a histogram, we see here that there's actually a range in the minimum and a range in the maximum, meaning there is a little bin here between 9 and 12 is our lowest values, and between 33 and 36. We don't know the exact values in those bins. We just know that there is some values between 9 and 12, and there is some values between an ACT score of 33 and an ACT score of 36. So we see the data varies from somewhere between 9 and 12 to somewhere between 33 and 36. Putting it all together, we would say the data was collected on ACT scores for students in a stats class. The distribution appears to be slightly left skew and unimodal. There do not appear to be any outliers. The distribution is centered somewhere between 24 and 27, and the data varies from somewhere between 9 to 12 to ACT scores of somewhere between 33 and 36. This would be a model FRQ response if you're describing this distribution. Again, we're going to get more specific ways to measure center and spread next lesson. Last but not least, I want to give you a little hint as to how to describe the shape of Stemplots. So here's some third grade test scores in a Stemplot. It's kind of hard to describe the shape because Stemplots are a little bit cattywampus with their orientation being vertical. So we're going to shift it so that it becomes horizontal. And we want to make sure that our lower stems on the left side, higher stems on the right side, so we have the data in the right order. And now we can analyze the shape. In this case, we can see that if we draw the shape rough outline, we can see there's a big mode here, and then it kind of drops off like that. So this is an obvious left skew yet again. Different skews in different histograms kind of look like this. We see symmetric, right skew and left skew, and if you imagine flipping them and turning them on their side, we can see that shape pretty clearly. So that's it for our lesson today. Thank you for joining, and have a good one.